Dear students, we humans have always been keen to know what universe is made of. What are those fundamental particles which we are made of? This lecture is about fundamental particles and their interactions. So what do we mean by fundamental particles? The particles whose further subdivision is not possible is called fundamental particle. From our school knowledge, we would say that atom is a fundamental particle. Atom is the smallest one. But no, atom has its structure. Atom has electrons and nucleus. So electron is the one of the lightest particle, and those lightest particle or light particle are called leptons. In nucleus we have neutrons and protons. Further subdivision of neutrons and protons is also possible. These tiny particles are called quarks. The neutrons and protons consist of quarks. So we have fundamental particles, quarks and the leptons. Now we will see how these fundamental particles, these leptons and the quarks interact with each other. There are four types of fundamental interactions. So let's look at the electromagnetic interaction. Let's consider two tiny particles having electric charge Q1 and Q2. From Coulomb's law, the electric force between these electrically charged particles is proportional to the product of their charges and inversely proportional to the square of the distance between them. So, who carries this information between these charged particles? The information of electromagnetic interaction between the charged particles is carried by photon. So the particles which carry the information of the interaction are called messenger particles. These particles are bosons. Bosons can have spin 0, spin 1, spin 2, integer spin. So in electromagnetism, the messenger boson is photon. Next is weak interaction. So weak interaction carried by Z boson and W boson. Let's consider the example of E plus E minus annihilating to quark and antiquark. So this interaction is carried by the neutral current or the neutral weak boson, that is called Z boson. Next is charge current. So let's consider the scattering of electron and U-type quark. So this interaction is carried by the charged boson, charge vector boson is called W boson. So in weak interaction, what are the matter particles which can interact by weak interaction? Quarks and the leptons. Electron is one of the lepton. And what are the messenger bosons? We have two messenger bosons, Z boson and W boson in weak interaction. So let us come to strong interaction. In a strong interaction, only quarks and gluons interact via strong interaction. The first example is annihilation of QQ bar, which then decay to QQ bar. This happens via exchange of the gluon. There is a special thing about a strong interaction. The gluons interacts with themselves. Means we have self interaction of gluons in the strong interaction. So production of QQ bar can happen via annihilation of two gluons. So we can see this gluon self interaction. So we have one messenger boson in a strong interaction. That messenger boson is called gluon. Now let's look at well-known gravitational interaction. From our schools we know that by virtue of the masses, two particles or two bodies attract each other. This force, the attraction force between them is proportional to the product of their masses and inversely proportional to the square of the distance between them. This is the gravitational interaction, or this is the form of gravitational force. So I have shown a table here in which you can see all 4 types of forces and their relative strength. So the strongest one, as we can see, why we call it strong force. The strongest one is strong force, relative strength is 1. In electromagnetic force, the experiencing particle means the particles which interact via what? They interact via messenger bosons. So electrically charged particles interact via photons in electromagnetism, and relative strength is 10 to the minus 2. In weak interactions, the matter particles which play a role or which interact via weak force are quarks and leptons, and this weak interactions happens via